Climate change and the dinosaurs. Volcanoes and asteroid impact climate-related extinctions. The prevailing theory of the dinosaur extinctions is said to be a comet or meteor strike, anyway, an Earth impact event, evidenced in the KT iridium layer, and it's found worldwide. The study suggests that even though the CO2, the carbon dioxide, was high during the Cretaceous, it could still turn cold very quickly, abruptly. So obviously, some kind of a stronger force, an impact, or some kind of a catalyst operated at that time. And we have images of the KT boundary, the 1-inch iridium layer, exposing 10 miles west of Trinidad, Colorado. The element iridium is very rare on Earth, but concentrated in meteors and in comets. The same iridium layer is found in several exposures around the world and corresponds age-wise with that of the Chicxulub meteor crater, the Yucatan Peninsula meteor impact, that is, in Mexico. Now, according to Plymouth University press release, this is from What's Up With That, scientists identify freezing times for the Cretaceous dinosaurs, and this is a summary. The scientists studied fossils and minerals from Arctic Svalbard in Norway, and they discovered evidence that the greenhouse climate of the Cretaceous period was punctuated by a sudden drop in global temperatures. The drop, estimated to have occurred some 137 million years ago, so it was way before the 66 million years ago impact in Mexico, 137 million years ago, during a time when dinosaurs did roam the Earth, it would have seen the islands fall from an average of 13 degrees centigrade ocean temperature to as low as 4 degrees. The findings, which were published in the journal Geology, featured the highlights in Nature Geoscience, will further contribute to the debate over climate change, as they appear to contradict the common model, which links high levels of carbon dioxide, as recorded in the Cretaceous area with reduced polar ice caps. Despite being located in the Arctic Circle, Svalbard of Norway was home to numerous species of dinosaurs, and was typically characterized by warm, shallow seas and swamps. But the research team, led by Dr. Gregory Price, University of Plymouth, found evidence in fossils and carbonate materials preserved in marine rocks in the region of a transient shift in cooler glacial conditions around 137 million years ago. Dr. Price said, "At certain times in the geological past, the world has been dominated by greenhouse conditions with elevated CO2 levels and warm polar regions, and therefore these are seen as analogies for future global climate. But this research suggests that for short periods of time the Earth plunged back to colder temperatures, which not only poses interesting questions in terms of how the dinosaurs might have coped with this, but also over the nature of the climate change itself. Why did it happen?" Dr. Price, along with Dr. Elizabeth Noon of Johannes Gutenberg University in Mainz, Germany, first visited Svalbard in 2005, and they did so to collect fossils and samples in an area famed for a number of paleontological discoveries, including giant marine reptiles such as the pliosaurs and the ichthyosaurs. The samples were analyzed back in Plymouth and prompted return trips to the area to gather even more evidence. Dr. Price said, "The flourishing of the dinosaurs and a range of other data indicates that the Cretaceous period was considerably warmer and boasted a very high degree of CO2 in the atmosphere. But over a period of a few hundred or a few thousand years, ocean temperatures fell from an average of 13 degrees centigrade to between 8 and 4 degrees. Although a short episode of cool polar conditions is potentially at odds with a high CO2 world, Our data demonstrates the variability of climate change over time scales, he said. And now concerning the volcanoes asteroid impacts and what drove the ancient climate-related extinctions. Again, on what's up with that. Warming pulses in ancient climate record link volcanoes, asteroid impacts, and dinosaur killing mass. Well, we know we've had a number of asteroid impact sites, even recently found, just by scientists observing images on Google Earth. And two of the recent findings are one in 2004 in southwest Egypt, in the desert. They found an asteroid impact site there from Google Earth images. And around the impact site, they found volcanic areas, lava volcanoes, cinder cones and lava. And they examined the whole area. They put everything together as that being an impact of pretty recent. It was about 5,000 years ago, that is 3000 BC. And they claimed that that impact caused volcanic eruptions, tremendous earthquakes and volcanic eruptions, ash clouds, and temperature changes. The impact made and of course the volcanic eruptions made the earth boil. Perhaps that's why they have found Egypt glass, the Egyptian glass made from the sand. And they were wondering perhaps it was an atomic blast of some kind. Well, perhaps it was from this impact. But anyway, that was one of the recent findings having to do with an asteroid strike and volcanic activity. And the other one was 10 years later, in Iraq, an asteroid strike in Iraq. They found the volcanic impact crater, and volcanic eruptions associated with that as well. And as we said, there is a difference that you can tell a volcanic crater from an asteroid impact because of the iridium that's found there. They can tell because of the type of minerals that they can find there. That tells them if it's, for example, this here is an asteroid impact site in Arizona, and it's not a volcano. It's not a volcanic crater. So that's how they can tell. And also, the impact site and volcanic eruptions in southwest Egypt is what caused the eventual demise of the pharaohic kingdoms of Egypt, even up to the time of Cleopatra, which is where, around Mark Antony and Julius Caesar, because she tried to get alliance with Rome in order for them to protect. They had tremendous famine, tremendous economic loss, and social upheaval. You can understand what goes with all this type of, all these problems. So, the asteroid impacts linked with volcanic eruptions. And we're going back now to our topic, the dinosaur killing. Ann Arbor says, the new reconstruction of Antarctic ocean temperatures around the time of the dinosaurs' disappearance, 66 million years ago, with the Yucatan Peninsula impact there, supports the idea that one of the planet's biggest mass extinctions was due to the combined effects of volcanic eruptions and an asteroid impact. Two University of Michigan researchers and Florida colleague found two abrupt warming spikes in ocean temperatures that coincided with two previously documented extinction pulses near the end of the Cretaceous period. The first extinction pulse has been tied to massive volcanic eruptions in India, the second to the impact of an asteroid or comet on Mexico's Yucatan Peninsula. Both events were accompanied by warming episodes. The UM-led team found the analyzing chemical composition of fossil shells using recently developed technique called the carbonate clumped isotope paleothermometer. Wow. The new technique avoids some of the pitfalls of previous methods, showing that Antarctica ocean temperatures jumped about 14 degrees Fahrenheit during the first of the two warming events, likely the result of massive amounts of heat-trapped carbon dioxide gas released from India's Deccan Traps volcanic region. The second warming spike was smaller and occurred about 150,000 years later, around the time of the Chicxulub impact in Yucatan, Mexico. Okay, so 150,000 years later. This new temperature record provides a direct link between the volcanism and impact events and the extinction pulses, that link being climate change. This is what Sierra Peterson said, postdoctoral researcher at the Department of Earth and Environmental Sciences. She said, we find that the end Cretaceous mass extinction was caused by a combination of volcanism and meteoric impact, delivering a theoretical 1-2 punch. The cause of the Cretaceous Paleogene, or KPG, mass extinction that wiped out the non-avian dinosaurs and roughly 3/4 of the planet and animal species, 3/4, 75% extinction. Can you imagine? 66 million years ago has been debated for decades. Many scientists believe the extinction was caused by an asteroid impact. Some think regional volcanism was to blame, and others suspect it was due to a combination of both these things. The 1-2 punch. Recently, there's been growing support for the so-called press pulse mechanism, the press of gradual climate change due to the Deccan traps of India volcanism, followed by the instantaneous catastrophic pulse of the impact. And together, the events were responsible for the KGB extinction, according to theory. Now, the new records of ancient Antarctic ocean temperatures provide strong support for the press pulse extinction mechanism. Pre-impact climate warming due to volcanism may have increased ecosystem stress, making ecosystems more vulnerable to collapse when the meteor finally hit, according to Peterson and co-author Kiger Holman of So to create their new temperature record, which spans 3.5 million years at the end of Cretaceous and start of Paleogene period, researchers analyzed the isotopic composition of 29 well-preserved shells of clam-like bivalves collected on Antarctica, Seymour Island. These mollusks lived about 65.5 to 69 million years ago in shallow coastal delta near the northern tip of Antarctica. And at the time, the continent was likely covered by forests, coniferous forests, unlike the giant ice sheet that is there today. It was forest, lush and green. Now, remember that we, at that time, 65, 69 million years ago, that's just about the time Antarctica and Australia were very close together, if not connected. This is the time when a lot of the continents were very close to each other, and they were sort of still somehow swimming around. Now, the 2 to 5 inch long bivalves, the mollusks, their shells incorporated atoms of the elements oxygen and carbon of different masses, or isotopes, in ratios that reveal the temperature of the surrounding seawaters. The isotope analysis showed that seawater temperatures in the Antarctic in the late Cretaceous averaged about, it was very light, 46 degrees Fahrenheit, punctuated by 2 abrupt warming spikes. Quote, a previous study found that the end Cretaceous extinction at this location occurred in 2 closely timed pulses, Peterson said. These 2 extinction pulses coincide with the 2 warming spikes we identified in our own temperature record, which each line up with one of the 2 causal events. Unlike previous methods, the clumped isotope paleothermometer technique does not rely on assumptions about the isotopic composition of seawater. Those assumptions thwarted previous attempts to link temperature change and ancient extinction on Seymour Island in Antarctica. So, now the cause of the end Cretaceous mass extinction is still debated due to difficulty separating influences of two closely timed potential causal events: the eruption of the Tramps volcanic province in India and the asteroid impact in Yucatan, Chicxulub meteorite. So here we combine published extinction patterns with a new clumping isotope temperature record from a hiatus-free expanded KPG boundary from the Seymour Island in Antarctica. Local warming may have been amplified due to simultaneous disappearance of continental or sea ice. Intrashell variability indicates possible reduction in seasonality after decamp eruptions began, continuing through the meteorite event. Species extinction at Seymour Island, that's in Antarctica, occurred in two pulses that coincide with the two observed warming events, directly linking the end Cretaceous extinction at this site to both volcanic and meteoric events due to climate change. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.